What's up, guys? Welcome back to the channel. Today on this video we'll be doing this question paper that you see here. So this is a national certificate for mathematics and 4, and this paper was actually written on the 24th November 2025. It was an X paper which took about 3 hours to be written. So on this video, we'll be doing only question 1, and we want to continue into question 2, question 3, question 4, and question 5 later on. So I'm going to leave timestamps on this video just in case you want to watch this question paper or this memo in a order that you like. Alright guys, so before we start though, you can always share, like, subscribe to the channel, and also comment if you have any comments. All right, people. So let's go to question 1 and let's do this question paper. Here's our question 1. As you can see, question 1 has 3 questions, which is 1.1, 1.2, and 1.3. So these questions, they have their own sub questions underneath them. So question 1 is actually graphs and functions. So we're gonna start with 1.1, as you can see there, and then we're gonna do it. So what I'm going to do is I'm gonna create space and then we do 1.1. So here's our 1.1. So the question goes like this: draw a neat sketch of the graph of y plus root 9 minus x squared is equaling to 0. Now this graph here, guys, it's actually the semicircle graph, just in case you know. So what we have to do here is we have to make y subject of the formula. Let's do it. We say y is equaling to, if you transpose all of this to the right hand side, this is going to be negative root 9 minus x squared, right? So this here, guys, is actually the semicircle graph. Just in case you didn't know, the semicircle graph looks like this, especially for one with y. Just write it here. The general formula, it looks like this: plus or minus, and then we have r squared minus x squared. This one is for y. Based on this question that we have here, wherever we have r squared there, we have 9 there. It means here our r squared is equaling to 9, right? So in order for us to find r, we have to square root there, and then r is going to be equaling to 3. So this here, guys, is our radius. Now let's look at the signs there. We have the sign which is negative there. When the sign is negative, this basically means that our semicircle is going to cut on the negative side of y, right? Since it's equaling to y. So let's draw our Cartesian plane. All right, so here's our Cartesian plane. Since our radius is 3, we can just insert the point where 3 is: positive and negative 3 on x-axis, positive 3 and negative 3 on y-axis. So, like I said, this is a semicircle, but it's cutting on y. So this is a lower semicircle. Because of this negative here, this semicircle is going to cut on the negative side of y. So when I have this point here, and that point there, and this point there, and then we connect these dots. There we go, guys. So this is our graph. You can name it y is equaling to negative 9 minus x squared. That is our graph here. So this here is out of 2 marks. Guys, do not forget, whenever your semicircle graph is equaling to y, just know it's cutting on the y-axis. But then if it's negative, it's cutting on the negative part of y-axis. Okay. If it's positive, then it's going to cut on the positive part of y-axis. So this is a lower semicircle. All right, people. So this is how you do this one. Just in case you didn't understand, you can leave a comment in the comment section. But if you did understand, you can also like, subscribe to the channel if you haven't subscribed, share the videos to your friends, and also, guys, recommend people to the channel. All right, we are done with this 1.1. Let's go and do 1.1.1. All right, guys, here's our 1.1.1. Let me highlight it here. As I said, 1.1.1 is a sub question for 1.1. Now the question is so simple here. They say there is the inverse of y plus root 9 minus x squared is equal to 0, a function or a relation. Now this one here, guys, you have to be careful when you do this one. They're asking whether the inverse of this graph is a function or a relation. Now the inverse of this graph here, there are two ways of writing the inverse. It's simple. You can swap x and y, and that's gonna be your graph. Let's say the inverse of f of x. So what we have to do there is swap x and y. So from this here, from this equation, we substitute by x, and then this is gonna be equaling to negative minus y squared. All I did here, I just swapped x and y, and that's it. So you can draw this graph to see whether it's a relation or a function. Now, if I were to draw this graph, I will know that our r here is gonna be 3 as well. This here, right? The square root of 9 is 3. Now, since it's equaling to x, this basically means that we're gonna cut on x-axis. But since it's negative here, this means that we're gonna cut on the negative side of x-axis. So still we're gonna cut at -3, +3, and -3. So we're gonna cut on the negative side of x. So this one here is our inverse graph, the blue one there, guys. So the blue graph that you see there, that is gonna be our inverse. Now remember, they never said draw the graph. I'm drawing this just to explain how I'm answering the one of the answers there, because we need to select whether this inverse it's function or relation. The answer here is relation. Relation. There we go. So the answer for this one here, it's relation there. Why is it relation? Well, one of the reasons we cut y twice. If it's a relation, guys, the graph will cut y twice or more. So as you can see, the blue graph there is cutting the y-axis twice there. So another way to find out whether this graph is a function or relation, you check within the domain of the graph. Okay. For example, if we draw a vertical line within the blue graph, which is the inverse, if we take any x value, let's say -1, and we draw a vertical line within the domain of this blue graph, we want to have this point here. Okay, so this point, obviously our x is going to be -1, and our y, for now, let's just say it's just positive y. Again, if you extend this line going downwards, we're going to have a point that cuts again the blue graph, but this time around we're going to have x is -1, and our y is going to be just be negative there, even though we don't know the exact value of y. But this states that one x value gives you two y values, so this is one of two. It's another method that you can use to check whether the graph is function or relation. So this also proves that our graph here, the inverse, is a relation. I hope you guys managed to understand this one. Again, if it so happened that you didn't understand, you can leave a comment in the comment section. You can also like the video if this video helped you to understand. And if you haven't subscribed, subscribe to the channel, and don't forget to share the videos to your friends. All right, people, we are done with this question 1.1.1. How about we look at 1.1.2? All right, guys, we are done with 1.1.1. Let's look at 1.1.2. Now the question here states that is the inverse of y plus root 9 minus x squared equaling to 0 continuous or discontinuous? So the question here, they are asking, is this the inverse continuous or discontinuous? If you still remember, the inverse look like this. By the way, I did erase it earlier, the blue graph there. So the question is it continuous or discontinuous? So the answer is continuous. I'll explain to you later on. Let me just write continuous there. Right. So it is continuous because you can draw this blue graph without breaking a line. When a graph is continuous, it's when you can draw it without breaking a line. Let me draw the Cartesian plane and make an example here. We have a graph like this one here. We can say this is a straight line graph, right? This is a straight line graph. As you can see, this graph that we just drew there, you can draw it without breaking a line. You can just draw a line that is going straight without you lifting a hand or breaking a line. So when it's like that, it's continuous. As you can see, going back to the question, the inverse graph of this one that is given to us, it is continuous because you can draw it without breaking a line. An example of a graph that is not continuous, it's the one that follows now. Let's say we have a hyperbola. Remember hyperbola? A hyperbola like this one here. In order for me to complete this graph here, I have to break the line and draw another part on the fourth quadrant. So in order for us to draw this graph here, we have to break the line. Okay. So this type of a graph here, it's discontinuous. But as for this one here, that is continuous. So I hope you guys understand, because these are free marks, guys. They're very easy to get, very easy to understand. They're just free marks. So just in case you didn't understand, you can leave a comment on the comment section. Even if you did understand, guys, you can comment as well. And if this helps you to understand better, do not forget to like and subscribe to the channel if you haven't subscribed. Don't forget to also share this information or these videos to your friends. Right, people, we are done with this one. It was straightforward. All right, guys, so here's 1.2. Now this is a different question on its own. They want us to draw or sketch a graph of 9x squared is equaling to negative 4y squared plus 36. So this graph that you see here, we need to simplify it, guys. How about we take this negative 4y squared to the left hand side? On the left hand side, we have 9x squared, right? If we take this negative 4y squared to the left hand side, it's going to be positive 4y squared. And then on the right hand side, we're going to be left with 36 there. Now, when it's like this now kind of look like something that we are familiar with, which is an ellipse, right? Remember, let me just write the formula here for an ellipse. Ellipse is like this. You have x squared divided by a squared plus y squared divided by b squared. This is equaling to 1, right? So as you can see, we do not have the equaling of 1 there. So we need to make it to be equaling to 1. So when we do that, we must divide by 36 throughout all the terms there. We divide by 36, divide by 36. If you divide by 36, on the first term, we will have x squared divided by 4 plus, and then on the second term, we're going to have y squared divided by 9, and this is equaling to 1. Now, this kind of look like this now. As you can see, a squared is dividing x squared. From our equation here, our a squared, we can say, is equaling to 4, right? And then our b squared, the one that is dividing y squared from this equation there, it's 9 on this one. Now let's continue. Let me create a little bit of space here so that we can able to solve this problem. So we know that in order for us to find a, we need to square root a and also square root 4. Same thing here with b squared. We square root b squared and 9. So a is equaling to plus or minus 2, because the square root of 4 is 2. And then b is equaling to plus or minus 3. Now going back to our equation there, just create a space, our general equation. I hope you can see, guys. Going back to this equation there, as you can see, we have a squared, which is dividing x squared. So a is actually the x-intercept. We have b squared that is dividing y squared, meaning b is the intercept of y. So let me draw the Cartesian plane and let's draw the graph. All right, so here's our Cartesian plane. As you can see from our calculations, a is plus or minus 2. And we said a, since it's dividing x, is the x-intercept. So on the x-intercept, you're gonna write in 2 there, and negative 2. There we go. This for x-intercept. And then for y-intercept, we have b there, which is plus or minus 3. So we're going to have positive 3 there and negative 3 there. And then from there, you connect the dot. Remember, the ellipse, guys, is a graph that looks like an egg. Just in case you didn't know, guys, it looks like an egg like this, right? And then here, let me just do this. Then here, the intercept there, it's b, and that is going to be negative b. And the intercept there, it's a, and that is going to be negative a. There we go. Just in case you didn't know. So in our case, our a, it's plus or minus 2, and then our b is plus or minus 3. So let's connect the dot. Let me use a different color there for us to draw the graph. There we go. So here is our graph. So this is then ellipse, the graph that they wanted you guys to draw. So make sure that you show this intercept because it's very, very important. And then don't forget to label the graph as well. Well, you can label it from the original equation or the one that you just simplified into. So I rather label it to the one that I just simplified into. Still okay. There we go. So this is our ellipse there. So this is out of 2 marks. So some of the things, guys, are not necessary for you to do them. It's just for me to explain to you guys. Anyway, I hope this part of the video helped you to understand. If you do not understand, again, guys, you can leave a comment on the comment section. Even if you did understand, comment on the comment section. And if this video helped you to understand better, you can always like, share, and also subscribe to the channel if you haven't subscribed to the channel. All right, people, we are done with 1.2. Let's look at the next question. All right, the next question is as follows. It's 1.2.1. They want you here to tell us what is the domain of the graph 9x squared is equal to negative 4y squared plus 36. What is the domain? When they ask about the domain, they're actually asking about the x values that are part of this graph here. So as you can see, our x values here on this graph, it's actually 2 and negative 2. So basically they're asking from x-axis, where does it start, where does it end, this graph of ours. So the domain, it's actually negative 2 to 2. You can write it like this. This is fine, guys. This is our domain from this negative 2 to 2. That's it. So whenever they talk about domain, they're actually asking you to give us the values of x that are part of the graph, right? So we can also write x is the element of real number there. It's fine. Even if you don't write it, I don't think it's going to be a problem. This is out of 1 mark, guys. I hope you guys understand how to get the domain here. Let's look at the next question. As you can see, here's our next question, 1.2.2. Now, the next question, they're asking, what is the range of the graph 9x squared is equal to negative 4y squared plus 36? The very same graph that we just drew there. Now they're asking about the range. Again, guys, the range, we are looking at the y-axis. So we're looking for the values of y, where the graph starts and where it ends. Now, as you can see, this is going to be negative 3 and 3. So the range, you can write there, range is from negative 3 to positive 3. Y is the element of real number. There we go. So this here, guys, is the range. It starts from negative 3 to positive 3. So that's how you're going to get the range. So whenever they talk about the range, it's on the y-axis. So I hope you guys understood how to answer these two questions. They're not really that difficult for this one. It's really straightforward, but just in case you didn't understand, again, you can leave a comment on the comment section. I'll try to answer it to my level best. Even if you did understand, you can always comment, like, share, and also subscribe to the channel if you haven't subscribed to the channel. Well, people, we are done with 1.2. I think it's time for us to do 1.3. So let's look at 1.3. All right, let's look at 1.3. Now, 1.3, they want us to draw a neat graph of y is equal to log base ex. So this is actually a log graph. So this one here, this log graph is the same as y is equaling to ln x, right? Just in case you didn't know, guys, ln x is equaling to log base e then x, which is the same question that we have there, right? So it's up to you how you're going to draw this graph. You can draw it that way from the original equation, or you can draw the ln x graph, but it doesn't matter. What matters is how you draw the graph. So I usually tell people to use the table. I find it easy to use the table, guys. Please use the table. As long as you understand it, use it. I'm gonna start by putting 0 comma 1, right? 0 comma 5, we put 1, and we put 2 there. Guys, these values that I put here on x, as long as they are positive, they are fine. As long as x is greater than 0, that's good. Please do not put x that is less than 0. You can put an x that is greater than 0. X cannot be equaling to 0 again on this one. Let's put this on a calculator. When x is 0 comma 1, what is our y? This is going to give us negative 2 comma 3. There we go. So when x is 0 comma 1, it's going to give us negative 2 comma 3. When x is 0 comma 5, what is it that you're gonna get there? When you're gonna get negative 0 comma 69. Let's just make it 7 like this. Okay, now when x is 1, what is gonna be our value there? Our y is gonna be 0. And then our when x is 2, what is gonna be our y there? It's gonna be 0 comma 69. Let's just make it 0 comma 7. There we go. Now let's do the Cartesian plane and let's draw our graph here. Here's our Cartesian plane. Now let's start with this first point here. When x is 0 comma 1, what is our y? Our y is going to be negative 2 comma 3. So 0 comma 1 for x is very close to 0. Let's say it's somewhere here. So we have to draw a line that goes downwards like this, right? Vertical line, guys, right? Our y is going to be negative 2 comma 3. So negative 2 is here, 2 comma 3 is in the middle, somewhere there. Also draw a line that goes there. Wherever these lines meet, this is our point there. I hope you guys can see, right? Then let's look at this point here. When x is 0 comma 5, what is our y? Our y is going to be negative 0 comma 7. So 0 comma 5 is here. You draw a vertical line again here. Negative 0 comma 7 is very close to negative 1. So it's somewhere there, guys. There we go. This point there. And then when x is 1, our y is 0. This is the point there. So this is going to be point here. Our x is 1, our y is 0 on the x-axis. There we go. And then when our x is 2, this is 2, our y is going to be 0 comma 7. 0 comma 7, let me draw a line first here. Okay. And then 0 comma 7 is very close to positive 1 there. Wherever they meet, this is going to be our point. Then from there, you just connect the dots. So let's connect the dots. There we go, people. So this is our graph for the log. Just in case, guys, you don't know how to draw this, rather use the table method. It's easy, straightforward. Might take you some time, but it's not that difficult to follow. Okay. So some of you might ask, why don't we have negative x on our table there? It's because our graph asymptotes. As you can see, our graph doesn't pass the y-axis. It asymptotes on y-axis. So if it asymptotes on y-axis, it means it doesn't go on the negative side of x. It means it doesn't pass to the negative side of x. So this is our graph. So one of the most important thing that you must always show this point here. Let me just write it. 1 and 0. When x is 1, our y is going to be 0. Show this point. Another thing, the shape is very important. Exactly the way I've drawn it should be like that. Your graph should not cut y. Once it cuts y, it's incorrect, especially for this one here. So it only asymptotes at y axis, right? And another thing that you must not forget is to label the graph. So this graph here, it's actually y is equaling to log base ex, or you can write it as y is equaling to ln x. One of the two, it's okay, right? So this table here, it is not necessary as long as if you know how to draw the graph. If you don't know how to draw the graph, rather use the table. Guys, we are done with question 1. I hope this video helped you to understand this question 1. Just in case you didn't understand this question here, 1.3, please do not hesitate to leave a comment in the comment section. I'll try to help you to my level best. But if this video helped you to understand, don't forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. Right, people, next time when we meet, we'll be doing question 2 of this question paper. So make sure that you hit the bell notification, so whenever I upload a video, you will be notified as soon as possible. Right, people, see you on the next video. Thank you very much for watching. Till next time, cheers.